Okay, students, so today I will discuss question number 8 from your question paper. Okay, unit test question paper. Some students were having doubt on this. Okay, so most of you haven't written this portion, equivalence class of 5. I think you have doubt on this one, so try to listen carefully and try to understand. Okay, so what it says in the question was a relation R is defined in the set Z, means set of integer, by relation this one. So this is the relation given. What is the relation between the elements? A and B relation is A minus B. When you subtract this one, it must be divisible by 5. So in this set, what kind of element will be there? Order pair. What kind of order pair? If you subtract this 2, this subtraction, whatever output it will give, that must be divisible by 5. So all integer, if you try to write down in this way, infinite it will come out. So you cannot write down, list all the elements here. So when you prove this one, you have to prove in general form. Okay, now see what is the proof first. Relation is given by this one, right? So the question was, is it possible to find equivalence class of 5? So equivalence class of 5, first thing what it was, first thing, the important thing about this one is, first, to find out equivalence class, you need to find whether the relation is equivalence valence relation or not. Okay, R is equivalence relation or not, you have to check. If it is equivalence relation, then only we can find out equivalence class. What was equivalence class? I will discuss again. So first important step is you need to find whether R is equivalence relation or not. Okay, so how I will check that one? Equivalent relation, 3 condition you have to, it must satisfy. What are those? It must be reflexive, this R must be reflexive, then symmetric, and it must be transitive. So reflexive, what was the definition? If in your relation set, whatever is the element here, in Z, what are the elements? Plus minus 1, plus minus 1, 0, plus minus 1, plus minus 2, all will be there, right? Plus minus both infinite elements will be there. So all these elements. So in your relation set, 0, 0 must be there. 1, 1 plus 1, 1 must be there. Minus 1, minus 1 must be there. Remember, A. For all A belongs to Z. If it is there in R, then it will be reflexive. So you have to check A will be there or not. For all A. For all A means integer whatever you have. For all those you have to check. A means what? Suppose A is 0. So 0, 0 is there or not. A is 1. So 1, 1 is there or not. Minus 1, 1 is there or not. Now obviously you cannot check from the set because it's an infinite set. So you need to use this one in general form. Okay, this reflexive you have to show in the general form. So how you will show? Very simple. See here which kind of element will be there? Those whose subtraction must be divisible by 5. Now see here, any element you take, 0, 0, suppose 0, 0, if I subtract it and divide by 5, will it be divisible or not? Obviously 0 you will get. 1, 1 will be there or not in this relation? Obviously yes. How I can check that? 1 minus 1, 0, divide by 5, it will be 0, it will give you, right? Minus 1 minus 1 will be there or not? Yes, of course, in the relation set it will be there because it will satisfy this relation. This minus this, how much it will be? Minus 1 minus minus 1, so it will be plus, this will be plus 1, so it will become 0. So 0, it is divisible by 5 or not? Yes. So in this way you take 2, 2, minus 2, 2, every element will be there in this relation set. So obviously it is reflexive. So how we will write down in general form? For all A belongs to Z, A comma A belongs to R will be there, right, in the relation set. So can I write in this way? So therefore R is reflexive. So can you see, writing portion is very simple. I have written in a general form, but this you need to understand practically first. Okay, simply don't write this. Okay, so R is reflexive. So first problem solved. Next I have to show symmetric. So for symmetric, what was the definition? For symmetric, definition was what? If AB is there in the relation set, then BA must be there. So if 0 is 0, so this to no problem, right? 0 0 if it is there, then 0 opposite to it, if you reverse the order pair, it will become again 0 0. So this is not a problem. The problem is, for example, 0 1 will not be there. Can you tell me other element? It will be, let me write 5 comma 0 will be there in this set, relation set. 10 comma 5, let me write 6 comma 1, this also will be there. In this way many element will be there. Now see, if you have AB, BA also must be there, means 0 5 also must be there. So see here, 5 0, suppose I will take any, you can take from this set, you take anything, any element, say 5 0, then 0 5 will be there or not? 5 0, why it is there? You can see 5 minus 0, it is how much? 5, divisible by 5, right? So it is there, 5 0. Now 0 5 will be there or not? So 0 5 obviously will be there. 0 minus 5 will be how much? Only sign will change here, minus 5. Now minus 5 will be divisible by 5 or not? Of course yes. So same way you can see 10 comma 5, it is there in the relation set, right? So why? 10 minus 5 is how much? 5. So 5 is divisible by 5, so it is there. So you will see 5 10 also will be there. Why? You can see when you subtract 5 minus 10, what will change? Same output you will get. Only the thing is sign will change. Minus 5 you will get. So minus 5 obviously it is divisible by 5. So if you take any element from here, its order, reverse order pair also will be there. 6 1 for example. 6 1 is there, right? 6 1. It is there in the relation set. Why? Because you can see 6 minus 1 5. 5 is divisible by 5. So no problem. It is there. So 1 6 also will be there. Obvious, because 1 minus 6 also will give you 5, except minus will be different here. Only sign will be opposite, so it will be divisible by 5, that also. So in this way you can see all the elements. So in general way, how you will write down? For, okay, let A comma B belongs to R. Suppose AB is there, then it's obvious, right? BA will be there. BA belongs to R. So in general we simply write like this, okay? So therefore R is symmetric also. Next, the last is transitive. I have to check. So transitive, how I will check? So to check transitive, first thing, what is the definition? If AB is there and BC is there, so first thing you need to have this kind of element. Then AC also must be there. If it is there, then only it will be transitive. So you can see this kind of element, if it is there, you will always see AC also will. For example, you take one. Suppose 5, 10 will be there, right? 10, say 15. So what is your A here? 5, B is 10. Can you see how I am taking the element? B is 10 again. B, right? A, B, B, C. This is different value I have taken. Now see, this is there in the relation set, right? 10, 15. 10 minus 15 is 5, divisible by 5. 5 minus 10 is minus 5, divisible by 5. So both are there in the relation set. Now 5, 10 also, 5 and 15 also must be there. You can take in this, randomly you take any element, always it will be there. So 5 15 will be there or not? Of course, 5 minus 15 is how much? 10, divisible by 5. So whenever AB is there, BC is there, AC also will be there. You can check that one, okay? So this is called transitive. Now this should not happen only for one or two elements. Whatever this type of elements are there, then AC must be there in that case. So whatever elements are there, this kind, in every case this must satisfy. AC also must be there, not only there. For example, another, if I take 0 5 5 15, 0 5 will be there in the relation set, 5 15 will be there in the relation set. See, I have taken A B B C format, so AC must be there, 0 comma 15 must be there. Will be there or not? Obviously divisible by 5, so BC also, AC also will be there. In this way, how I will write in general form? Same way, let A comma B belongs to R, B comma C belongs to R. Then can I say, then AC belongs to R. This I am writing in general format because it's not possible to write down in the listing format, because there are infinite elements. So transitive infinite element I have to check, that I can't do. It's impossible, right? So from this I have shown in the general form that R is reflexive, symmetric, as well as transitive. So can I say R is equivalence relation? Done. Now equivalence class. Equivalence class, first thing, what was the definition? Equivalence class of 5 will be what? It is a set, first thing. So most of you have not written in terms of set also. Equivalence class is a set. What kind of set? It is a set of elements in which it is related. Those elements are related to 5. So from where you will find out that set? From your equivalence relation only, from this set only. This R is equivalence relation, right? So from this set only you have to find out all those elements which are related to 5. You can see 0 is related to 5, so that will be there in the equivalence class of 5. Let me write down in different paper. So this question you have to solve everything logically only, okay? So in this R you have to find out 5 is related to what elements. 5 is related to what elements. All the elements. This element, second elements, if you write down in a set, that set is called, it is also written like this, equivalence class of 5. Okay, since you will get confused with this closed interval, or some student might get confused. Obviously it cannot be closed interval here, because in that case order pair was there, right? So equivalence class is written like this also, or you can write in words also. So equivalence class, basically what it was, equivalence class of 5 is a set. What kind of set? In this set, those elements will be there which will be related to this 5 in your equivalence relation set. This is equivalence relation set, right? We have already proved. So in this set you have to find out 5 is related to what element. Those elements you have to list here. Then that set will be called your equivalence class of 5. So in this case, obviously it is not possible to find out from this set, right? So in logically you have to find out what can be the element here which will be related to 5. All you have to list. So you can see 5 will be related to what kind of element. Is it possible that it will be related to 1 or 2 or 3 or 4, such kind of number, or 14 like this? Obviously no, it will be related to those number which are multiple of 5 and 0 also. 5 will be related to 0, right? And multiple of 5 only, that is minus 5, can I say? If you take minus 5, it will be related. Multiple of 5, you take anything other than multiple of 5, you try to take other numbers. It will never be a divisible by 5. So obviously it cannot relate it to other number other than multiple of 5. So 10 plus minus 10 I will write better. Don't try to write like this, okay? For example, for understanding I'm writing like this, plus minus both. Or if you write 5 comma minus 10 also. Okay, so let me write down properly. 5 comma 0 will be there. 5 comma 5 will be there. Next 5 comma minus 5 also will be there. Next will be 5 comma 10, 5 comma minus 10. In this way, multiple of 5, all numbers will come. 15, 5 comma minus 15. Other than this, you try to check out. If you take 1, other than 0, if you take 1, 2, 3, 4, or minus 1, minus 2, minus 3, minus 4, will it be related? Obviously no, that element will not be there in the relation set. So 5 is related to 0, 5 is related to 5, minus 5 also, 10, minus 10, 15, minus 15. The next will be 5 will be related to 20 and minus 20 also, right? In this way, what I can say, all these elements which you will get which are related to 5, if you collect that one in a set, that set will be equivalence class of 5. So 0, can I write plus minus 5? Next will be plus minus 10, plus minus 15, plus minus 20. In this way it will go on till infinite. So this is your equivalence class of 5. So I hope now it's clear. So first thing, try to understand the definition of equivalence class. Equivalence class of any element, if they ask equivalence class of suppose 10, then try to find out from your equivalence relation set. Okay, first thing, this must be equivalence relation set, then only you can find out equivalence class. From this set, find out 10 is related to which element. Those element, try to make a set. That set will be your equivalence class. Okay, I hope it's clear now.